There's a free trick that removes carbon buildup from your Honda's engine. No chemicals, no expensive shop visit, no special tools. Just a driving technique that Honda engineers actually built into the engine's design that almost nobody uses correctly. Carbon buildup is one of the most expensive and misunderstood problems affecting modern Honda engines, especially the 1.5T and 2.0T turbocharged models. Owners spend $400 to $800 on professional walnut shell blasting. Others dump expensive fuel additives into every tank hoping for results. But there's a $0 method that prevents and reduces carbon buildup using nothing but your right foot and some open road. I've been a Honda technician for over 15 years, and this is the technique I tell every single customer with a direct injection Honda to use. The ones who listen? Clean intake valves at 100,000 miles, smooth idle, strong performance, great fuel economy. The ones who don't? Carbon-coated intake valves at 60,000 miles, rough idle, hesitation, a $600 cleaning bill. Today, I'm exposing exactly what carbon buildup is, why it destroys Honda engines, and the $0 driving technique that prevents and reduces it. Let's get started. What carbon buildup actually is. First, let me explain what we're dealing with. Your Honda's engine produces combustion byproducts constantly: partially burned fuel, oil vapors from the PCV system, exhaust gases. In a healthy engine, most of these byproducts exit through the exhaust system, but some of them circulate back through the engine via the PCV, positive crankcase ventilation system. The PCV system routes oil vapors and blow-by gases from the crankcase back into the intake manifold to be burned again. This is environmentally necessary and legally required, but it has a side effect. Those oil vapors coat the intake ports and intake valves with a sticky, oily residue. In older port injection engines, fuel was sprayed directly over the intake valves on every intake stroke. That fuel spray acted as a constant cleaning agent, washing away deposits before they could accumulate. But modern Honda engines use direct injection. Fuel is sprayed directly into the combustion chamber, bypassing the intake valves entirely. Nothing cleans the intake valves, so the oily residue accumulates, bakes on from heat, builds up layer by layer. After 50,000 to 100,000 miles, intake valves can be coated with carbon deposits up to 3 to 4 millimeters thick. This restricts airflow into the cylinder, disrupts the air-fuel mixture, causes turbulence that reduces combustion efficiency. The result? Rough idle, hesitation under acceleration, power loss, poor fuel economy, engine misfires, and eventually, a professional cleaning bill that starts at $400 and goes up from there. Which Honda models are most affected? Carbon buildup affects all direct injection engines, but some Honda models are more susceptible than others. Most affected, 2016 to 2024. Honda Civic 1.5T, direct injection only, no port injection. Highest carbon buildup risk, 2018 to 2024. Honda Accord 1.5T and 2.0T, same direct injection design. Carbon accumulates quickly under city driving conditions. 2017 to 2024. Honda CR-V 1.5T. Short trip driving patterns typical of CR-V owners accelerate buildup dramatically. 2017 to 2022. Honda CR-V 1.5T in cold climates. Cold weather increases oil vapor production. Carbon builds up twice as fast. Moderately affected. 2019 to 2024. Honda Insight Hybrid. Atkinson cycle engine with direct injection. Lower RPM operation means less natural cleaning. Less affected. 2006 to 2015. Honda Civic. Port injection. Fuel washes intake valves constantly. Carbon buildup is minimal. 2013 to 2017. Honda Accord 2.4 liters. Port injection. Same benefit. Much lower carbon accumulation rates. If you own a turbocharged Honda from 2016 onwards, carbon buildup is a real threat that requires active management. The symptoms of carbon buildup. Before we get to the fix, here's how to know if carbon buildup is already affecting your engine. Symptom 1. Rough idle, especially when cold. The engine shakes or vibrates at idle when you first start it. Smooths out after a few minutes of driving. Carbon deposits cause uneven airflow into cylinders, creating an inconsistent idle. Symptom 2. Hesitation under acceleration. You press the gas and there's a brief stumble or flat spot before the engine responds. Restricted intake valves limit air entry, causing a momentary lean condition when you demand sudden power. Symptom 3. Engine misfires. Check engine light with misfire codes P0300, random misfire, P0301, P0302, P0303, P0304, cylinder-specific misfires. Severe carbon buildup causes inconsistent combustion in affected cylinders. Symptom 4. Decreased fuel economy. If your MPG has dropped 2 to 4 miles per gallon from your normal average without any other explanation, carbon buildup reducing combustion efficiency is a likely culprit. Symptom 5. Loss of power under load. The car feels noticeably slower, especially when merging onto highways or climbing hills. Restricted intake valves limit the engine's ability to breathe fully under high demand. If you're experiencing 2 or more of these symptoms, carbon buildup is likely significant, and the $0 trick becomes even more important. The science behind the $0 trick. Here's why this works. Carbon deposits are not indestructible. They're baked on organic compounds that can be burned off under the right conditions. Those conditions are extreme heat, high airflow velocity, and sustained high RPM operation. When your Honda's engine operates at high RPM under load, for an extended period, several things happen simultaneously. Combustion temperatures spike dramatically. Air rushes through the intake ports at high velocity. The PCV system produces less vapor at high load operation. These conditions combined create a self-cleaning effect. The extreme heat burns off light carbon deposits. The high-velocity airflow physically blasts heavier deposits off valve surfaces. The reduced PCV vapor output means less fresh carbon is being added during the cleaning process. The result, a measurable reduction in carbon deposit thickness. Not complete elimination. Not a substitute for professional cleaning on heavily carbonized engines, but a significant preventative measure that slows accumulation dramatically and reduces light deposits consistently. Japanese taxi companies discovered this decades ago. Their high-mileage Hondas running highway routes had dramatically less carbon buildup than identical engines doing city runs. The highway engines were self-cleaning through sustained high RPM operation. That's the science behind the $0 trick. If you want to take your Honda maintenance to the next level and keep it running strong past 500,000 miles, I've put together a complete maintenance blueprint just for Honda owners. It covers every fluid change, every inspection interval, and every trick to maximize your engine's lifespan. Click the link in the description to get your copy of the 500,000-mile car maintenance blueprint for Honda. The $0 carbon removal technique, the Italian tune-up. The technique is called an Italian tune-up. The name comes from the old mechanics saying that Italian drivers rev their cars hard and their engines stay cleaner. Turns out, there's real science behind the joke. Here's exactly how to do it on your Honda. Prerequisites. Your engine must be fully warmed up. Temperature gauge at the middle mark. Minimum 10 minutes of driving. Never do this on a cold engine. Cold metal, thick oil, and tight tolerances can't handle high RPM stress safely. You need a safe location, an empty highway on-ramp, a highway section with light traffic, or a safe open road. Never do this in traffic, on wet roads, or in residential areas. The technique for naturally aspirated Hondas, 1.5 liters, 1.8 liters, 2.4 liters. Step 1. Find an empty on-ramp or clear highway section. Step 2. In manual mode or sport mode, or third gear in a manual, accelerate firmly from 30 miles per hour to 60 miles per hour while holding the engine between 4,000 and 5,500 revolutions per minute. Step 3. Maintain 60 miles per hour in a gear that keeps revolutions per minute at 3,500 to 4,000 for 5 minutes. Step 4. Allow the car to coast down to 30 miles per hour without braking. Step 5. Repeat the acceleration sequence 3 times. Step 6. Return to normal highway cruising at 2,000 to 2,500 revolutions per minute for 15 minutes. Total technique time, 25 to 30 minutes. The technique for turbocharged Hondas 1.5T, 2.0T. The turbo version requires slightly different execution because boost pressure changes the dynamic. Step 1. Find an empty on-ramp or clear highway section. Step 2. In sport mode or manual mode, third gear for manuals, build boost pressure smoothly from 30 miles per hour. Step 3. Accelerate firmly but not abruptly to 65 miles per hour while maintaining 3,500 to 5,000 revolutions per minute and building full boost. Never spike the throttle suddenly from low revolutions per minute. This creates compressor surge in the turbo. Step 4. Maintain 65 miles per hour in a gear holding 3,000 to 3,500 revolutions per minute, where the turbo stays on boost for 5 minutes. Step 5. Lift off the throttle and coast down to 35 miles per hour. Step 6. Repeat 3 times. Step 7. Highway cruise at normal RPM for 15 minutes to cool the turbo under light load. Critical turbo warning. After completing the technique, never shut the engine off immediately. The turbo needs 3 to 5 minutes of light driving to cool down before shutdown. Shutting off a hot turbo immediately causes oil to bake inside the turbo bearing housing, creating carbon deposits that eventually destroy the bearing. Always cool down before parking. How often to do? This frequency recommendation based on driving style. Mostly short trips, under 5 miles, every 2 weeks minimum. Short trips create the most carbon buildup and provide no natural cleaning. You need to compensate aggressively. Mixed city and highway, once per month. Your highway driving provides partial cleaning. Monthly technique sessions maintain clean valves. Mostly highway driving, once every 6 to 8 weeks. Long highway trips already provide significant natural cleaning. The technique is preventative maintenance. Cold climate driving, below freezing regularly, every 2 weeks regardless of trip type. Cold weather dramatically increases PCV vapor production and accelerates carbon accumulation. How to know if it's working? After implementing this schedule for 3 months, here's what you should notice. Idle quality improves. The slight roughness or shake when cold diminishes. Throttle response sharpens. The hesitation under acceleration reduces noticeably. Fuel economy improves by 1 to 2 miles per gallon. Cleaner intake valves mean better combustion efficiency. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Combining the technique with these free habits. The Italian tune-up is most effective when combined with these additional zero-cost habits. Free habit 1. Highway driving on every long trip. Whenever you have a trip of 20+ miles, take the highway instead of back roads. Sustained highway driving at 60 to 70 miles per hour keeps intake air velocity high and temperatures elevated. Every highway trip provides partial carbon cleaning automatically. Free habit 2. Avoid excessive short trips. This is the root cause of accelerated carbon buildup. Carbon accumulates fastest when the engine runs cold and at low RPM. If possible, combine errands. One 20-minute trip causes far less carbon than 4 5-minute trips. Free habit 3. Let the engine warm up before using accessories. Running the AC, Heated seats and defroster on a cold engine increases load on a motor that's still warming up. This creates richer fuel conditions and more blow-by vapor, accelerating carbon accumulation. Wait until the temperature gauge reaches the middle mark before using heavy accessories. Free habit 4. Use quality fuel consistently. Top-tier fuels from Shell, Chevron, and Mobil contain higher concentrations of detergent additives. These detergents partially address combustion chamber deposits and reduce the rate at which new carbon forms. At current prices, the difference between budget fuel and top tier is 20 to 30 cents per gallon, worth every cent for a direct injection Honda. What the technique can't fix. This is important to understand. The $0 trick is powerful, but it has limits. What it prevents effectively: light to moderate carbon accumulation in engines under 80,000 miles that have been maintained with regular Italian tune-ups from early in the car's life. What it reduces but doesn't eliminate: moderate carbon buildup in engines between 60,000 and 100,000 miles with some existing deposits. What it cannot fix: heavy carbon buildup, typically 3 to 4 millimeters thick deposits in high-mileage engines that have never been cleaned or treated. If your engine already has severe symptoms, significant rough idle, consistent misfires, noticeable power loss, the Italian tune-up alone won't resolve the problem. At that point, a professional walnut shell blasting service, $400 to $600, is the correct solution. The cleaning procedure uses pressurized walnut shell media blasted through the intake ports to physically abrade carbon deposits from the valve faces. After professional cleaning, implement the Italian tune-up schedule immediately to prevent rapid reaccumulation. Think of the professional cleaning as a reset, and the Italian tune-up as ongoing maintenance that prevents you from needing another reset. The real-world results. Let me share what I've seen from customers who consistently use this technique. Customer A, 2018, Honda Civic 1.5T, 110,000 miles. Started Italian tune-ups at 20,000 miles, monthly schedule. Borescope inspection at 110,000 miles showed minimal carbon deposits, light gray film, no significant buildup, no professional cleaning needed, saved $600. Engine performance: identical to early ownership, no rough idle, no hesitation. Customer B, 2017, Honda CR-V 1.5T, 95,000 miles. Never did Italian tune-ups, mostly short city trips. Borescope inspection at 95,000 miles showed heavy carbon deposits, 3 millimeters plus on intake valves. Required professional walnut blasting, $580. After cleaning, implemented monthly Italian tune-up schedule. Follow-up inspection at 140,000 miles showed minimal reaccumulation. Technique working as intended. Customer C, 2019, Honda Accord 2.0T, 75,000 miles. Inconsistent Italian tune-ups. Did them for a while, then stopped for 6 months. Inspection at 75,000 miles showed moderate buildup, more than customer A, but less than customer B. Light cleaning service required, $280, then strict monthly schedule implemented. The pattern is clear. Consistent technique prevents expensive cleaning. Inconsistent technique slows, but doesn't prevent accumulation. No technique leads to expensive professional intervention. Final thoughts. Carbon buildup is the silent enemy of modern Honda engines. Direct injection is efficient and powerful, but it comes with a maintenance requirement that most owners don't know about. The Italian tune-up is the free solution that Honda engineers built into the engine's capability, but never told you to use. Find a safe highway, fully warm up the engine, drive it hard for 25 to 30 minutes, let it breathe, let it burn. Do this monthly. Combine it with highway driving habits, quality fuel, and smart short trip management. Your direct injection Honda will stay cleaner, run stronger, and go further between expensive professional cleaning services, or potentially avoid them altogether. That's the power of the $0 trick. And if you're serious about keeping your Honda running strong for the long haul, Don't forget to grab the 500,000-mile car maintenance blueprint. It's packed with every maintenance interval, fluid change schedule, and insider tip you need to get maximum life out of your engine. The link's in the description, and it's specifically designed for Honda owners who want their cars to last forever. If you found these tips helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.